So hello, am I audible? Just any one of you can confirm once.
Yes, sir.
Okay, thank you. So let's wait for 1 or 2 minutes, then we shall start today's discussion. Okay, so let's start today's discussion session. And so last week we mostly covered the basics of smart grid, that why smart grid infrastructure is needed nowadays, and what things have changed so that uh, the advancement in the smart grid architecture needs to be done, and the conventional power system that was there, why it had to be changed to a different one. It's like the okay, let me okay, yes. So why the things like the distributed energy resources being integrated with the the conventional grid in operation. So everything in entirety we discussed about why and how the things have changed, and what and why these things were needed to make the grid more smarter. Some grid monitoring scenarios were also being discussed, and something like the estimation part, like the the power flow direct control means power, how the things like load dispatch and the load dispatch, as well as what we've discussed. Mm, yes, load forecasting, and all these things, how they do impact the entire power system operation. And what, like in India, we are entire grid is divided into entire India is divided into five regional grids. So east, west, north, south, and northeast. So the blackout that happened in 2012, how it had happened, and all these things we have discussed. So today, mostly this week's lecture that covered in the lecture series, the five lectures that were there. So mostly they were means yes, distributed energy resources were one of the part, and some smart grid monitoring aspects like the RTUs, SCADA system, smart metering system, etc. So with the renewables in place, so most of the time we would be focusing on, since the renewables can be placed, means they are placed also in the transmission side, but if we can place them in the distribution side, that would impact more in the total system in operation, because we can reduce the transmission cost, right? So for that, what we think that these distribution system or the DERs would be placed mostly in the distribution side, so that the conventional operation system that was there, that was prevailing, and that is also prevailing in Indian context to some extent, we have changed to this uh, smart grid scenario. But mostly the conventional information flow, and although we have integrated the information flow and all these things in most of the places, like the optimal wired information flow from the uh, SLDCs as well as the ALDCs, etc., and all the substations. But still, there we need more improvement in this smart grid architecture part. So for that, we will be first discussing on the basic overview of the week, and then we would be going to the some, if you have any queries we can discuss, and I have also some questions that we can discuss in this session. So so let's begin today's discussion, right? So first of all, the overview that we need to take is that, so first lecture mostly detailed about this SCADA system in operation and smart meters, etc. So first of all, why SCADA system required? So why SCADA system is required? So yeah, last day also we have discussed that since the
Basically for monitoring and controlling purposes and getting information from the edge devices.
yes. So main aim of the SCADA devices is to fetch information from the uh, operational or the ground reality, that the parts, how the power system is performing. As per the data, from the basis of the data we can uh, conclude that whether something needs to be done or not. So since today's some of you were there last week also, but mostly the people are new. So just a 2 to 3 minutes overview of why and how these systems of these SCADA systems uh, helps in power system monitoring and control action, which is mostly needed nowadays in the smart grid context. So I will just give a brief overview, 2 to 3 minutes, so that everyone has a view that why this thing needs to be integrated for in the future, as well as how they are being operated in the present or time frame. So let me check whether the recording is, yes. Hmm. So from the data that we receive to these, suppose this is the master station. From to the master station, we have a huge lot of consider these as the substation. So these data would be transferred to the master station, and based on that, what we perform is the state estimation, right? So if some of you don't have the idea of what state estimation is, you can ask me now, or this is the basic backbone of the first operation that needs to be done whenever the data is received. So it, everybody has the idea what state estimation is, because last day I have discussed in detail, but if somebody were not there, so so mostly whenever the data is received, these data consists of noise being added which needs to be filtered, and also uh, suppose we need to find out the operating states of the system for all the buses. So V and delta are the voltage, sorry, not V, let's consider it as V magnitude. This is V magnitude and delta. So voltage magnitude and phase angle and its corresponding phase angle we need to find out for all the buses, right? So if we have the information of all these of the bus voltage phasors, that is the voltage magnitudes and its phase angles, then we can restructure or reconstruct the entire power flow scenario. So that mostly we need to in the practical context we need to see whether there is any violation of the limit or not. So I mean, limit in the power flows, current flows, all these things, because that would lead to some thermal breakdown. And if some because they in the blackout condition the breakers are also set to a value which is higher than the overload capacity, means at the overload, if it goes beyond the overload capacity, then that would result in suppose first breaker would open up, and that would lead to the load being shared to the other line, because all are interconnected systems. So in this way there will be a cascading of these of the lines being tripped, and based on that the entire power system would go in a total outage. So, considering this, we need to always monitor what are the present operating states of the system, and for that, and based on these states, we can restructure the power flows, line current flows, etc. And based on that, we can check whether the line limits are violated or not. So this is the basic backbone, and also the noise to be filtered. What are the noise? So noise is mostly, suppose in the present context, why I have used this term noise, because since we would be discussing SCADA system, right? So SCADA is the final substation in the suppose you can consider in the substation or in the master station, you have this HMI where the SCADA system is installed, and SCADA is the software where the data is being fetched from these RTUs which are deployed in the field. Okay, okay. So also somewhere we can also use the term IEDs, that is intelligent electronic devices. So since they are being deployed all throughout the field, and that data would be say, delivered to this substation, and there this SCADA system is installed, and in this SCADA system we would be, means since HMI human machine interface is there, so we would be getting an idea that what is the operating states. Now each and every devices which comes after the manufacturing, each and every measuring devices comes with a standard error deviation of error, means whenever in our younger days, whenever we used to go through or perform some experiments in the physics lab and all these things, physics lab, anything, means where would be we would be taking multiple readings and then averaging and just finding, taking around 5 to 6 readings and then averaging so as to get what is the operating condition. So why did we do that? Means there was a specific reason that if we take a more number of readings for the same quantity being measured or same quantity being measured, so for that, whenever we would be taking more readings, so and finally if we average them, then the errors means the deviation of these readings from their, means suppose we have 5 as the measurement, but for 5 readings we measured one. This is the true measurement, that is 5. We need to measure this 5, but we have measured 5.05, 4.98, 5.02, 4.96, etc. 5.005. So out of these 5 readings we would be averaging, and the value that we would be getting, that would mostly tend to 5. Means if we consider 5.05, so here this one is the lowest value. So something we would be getting nearer to 5, but lesser than the maximum of these things, so that if suppose this only one reading would have been taken, then that would definitely degraded the reading of that we have taken, because 5.05, this is a true value, but we would have taken 5.05, but whenever we would be averaging these 5 values, that would come somewhere between 5.2 or 1, 5.01 or 5.2, etc. So we are getting a much better value or better reading of the after averaging. So that's the case for the experiments that we did. But here only one measuring instrument is involved, and we know how this measuring instrument is being used, because we have an idea that this is a single instrument that we would be using. But in a power system there are thousands and lakhs, and means not thousand, means lakhs and crores of devices. So for each of these metering devices there are parameters involved, like aging of these devices, like their construction involved, their brands accuracies would depends upon the brands. Suppose we would trust mostly the companies which are, means, delivering a good quality report all in the market, but and for a longer time. So the trust issues comes with the brands. The better the brand, the more we trust them. So, and why do we trust them? Because in case of metering devices, the aim of these devices is to deliver best result. Best result in the former means we will have to maintain accuracy. So based on that, this SCADA system, now we have a huge amount of RTUs being deployed all throughout the and power system, all throughout the grid. So what we need to do is that we need to take, here we did just simple average, since we knew all the devices, only single device is involved. But whenever we have a large number of devices being involved, let's whenever we know that there are a large number of devices being involved, so this is device number 1, device number 2, and all these devices are from different brands, different companies, and also they're aging. Some are newer ones, some are old ones. So based on that, we prescribe weights. So what are the weights? Means weights, what are weights are the there would be more devices. Let's consider 3 for the time being. So what are these weights? These weights are the preferences that would be given to each devices. So w, okay, so this, suppose this is RTU1, these are the RTU numbers. So these are the weights. So how these weights would be assigned? These weights would be assigned based on the accuracy scale that is given along with the metering device. So the more accurate would be the more accurate the devices are, the more weight would be assigned to that device. And how to establish that? Because with the manufacturer, they, means when the manufacturer delivers the product, so alongside to it, they also deliver the information of the standard deviation of that device, metering device. So based on the standard deviation, what we can do is that, so more the standard deviation, suppose this is standard deviation for 1, this is standard deviation for 2, this is standard deviation for 3. Okay. So more the standard deviation, let us consider that delta gam 1 is greater than 3 greater than 2. So if the sigma 1 is greater than sigma 3 greater than sigma 2, so that means that this device is less accurate than this one. So the weight, the preference of weight, what would be the preference of weight? Any rough guesses how the weights would be assigned? Any rough guesses?
Highest weightage to the most accurate one and declining in that fashion.
Yes, yes. So W1 greater than W3 greater than W, sorry, W2 greater than W3 greater than W1. So it is inversely proportional, means the weights would be inversely proportional to the variances. Okay. So more it is, let's consider this is proportional. So it's inversely proportional to the variances. So based on this, whenever we perform an estimate, so the estimate what I have previously discussed is that this is the basic average. Okay, so that's the basic average. But for here we need, what we need to do is that weighted least square estimate. So we could have easily done the least square estimate if by removing this weight we could have easily done the least square estimate. And what the least square estimate means, that we would be taking the deviation from the true value of the measurement minus the true value of the squared of the measured minus 2. So this is the, and the our aim would be minimize this entire thing. Now, with the weights being prescribed for each and every instrument, because this becomes much more accurate, means the assumption of the problem becomes much more likewise to the pertaining context of the power system. So, what we do is that it is weighted least square, means W gets assigned, and along with that, this becomes weighted least square estimate. So, basic state estimation, what we call it as weighted least square estimators, run in the NLDCs, National Load Dispatch Centers, and these WLS estimator performs based on the data being acquired from all these RTUs. And now with the present context, PMUs are also there, but let's, if we consider that only RTUs, because mostly the RTUs are prevalent in the system, right? So based on these RTUs we can use this term that WLS estimator performs. So that's the importance of using this data, because we cannot use the data directly. So for that we need to remove the noise, and what is the noise part being involved, that is based on the weight. So we have ensured that all these small criteria are being assigned to the minimization problem, and after that we find the best possible or the best operating states of the system. So that is the use of this SCADA system or the metering devices for the smart grid monitoring. So coming to the SCADA part, so here we have the human machine interface where the readings would be present, readings would be there, and what we measure is that we have real-time data server, historical data server, application server, operation workstation, and operational operators workstation, means that human machine interface part. So what we measure is that voltage, magnitude. What are the measurements that we receive from the SCADA? Any idea? Last day also I have discussed. If somebody were there, then they would know. What are the measurements that we receive from the RTUs? Measurement from any rough guesses, because V and I is already mentioned, but and what is the what measurement is absent, and that is essential also, but it is still absent because system complexity do get enhanced because of the non-linear equations being encountered. So, but what are the measurements? Means any idea? Because last day we have discussed voltage and current, voltage magnitude is the measurement, not voltage phase angle. Okay, voltage magnitude. Generally, the measurements that are taken, power injections, means both real and reactive power injections, power flows, real and reactive power flows. Okay, so generally these are the measurements that we obtain from the RTUs in the master station, and based on that we perform the state estimation, and after that we find the results, that is V and delta. So these two results, V is V magnitude, not the V phasor, or and yes, so this information we can directly get from the RTUs, but just because of this phase angle is absent, and these to get this phase angle we need to perform. So that's the importance of SCADA system. Here's the data collection strategy being involved, where we can see that the data, and also one thing, the same is the condition, means whenever we, likewise when we get the data in the master station, similar is the case that when an operator needs to perform some remote operation, because everything is operating remotely. Nobody was willing to go to the bay and just switch on or switch off the breaker. So that's the aim of smart grid monitoring. So the grid, to make the grid smarter, we'll have to operate based on the data, and we'll have to ensure that data being obtained from these uh, is how much we would be prioritizing the data. So for that we need to be picture perfect in developing the system, so that we can rely entirely on the data being obtained. So for that, when the data is received from the RTUs to the substation, same is the condition that we need to perform a remote operation, like we need to open a breaker or close a breaker. So for that also, that information would be given in the master station, that is the human machine interface, and based on that a remote operation would be performed in the RTUs. Okay, so these input output ports, this is the purpose of that input output ports, that they would take the information as well as they would deliver the information to the hardware in operation, in the field, in the bay, anything. So also data collection, data processing needs to be done before being stored in the master station, and this is the main working idea of the RTUs. Also another part, that the these SCADA systems are mostly, they are vulnerable to uh, some, prone to some cyber attacks. So in the present day concept, in present day scenario 2019 also, uh, some cyber attacks are means the cyber attacks are taking a major toll in the entire power system smart grid architecture. Means with the power system becoming smarter, they are becoming more vulnerable to this kind of major threats, where the, suppose this is the, where the attacker's aim is to keep the measurements, like the measurements that we would be getting, these measurements would be deviated from their true operating condition. Now, here comes a fact that we also have a residual test along with the WLS scheme. This residual test, or rather we can say normalized residual test. Okay, normalized residual test along with the WLS do specify the power system operational overview. Okay, that is the V and delta. Means both these things work in unison so as to get these details. But the attackers design the attack vector in such a way that it means what is the a function of this normalized residual test is that suppose we have this is the if an attack vector is detected, or rather if an attack or any bad measurement is detected, for that case the standard deviation what we know is that mostly the data, this is the Gaussian bell shaped curve, so within 3 sigma entire data plus 3 sigma and minus 3 sigma, most 98.3 yes, mostly 98.3 or 99.3, so something like that. So most of the data would be concentrating within this interval 3 sigma plus 3 sigma to minus 3 sigma. So if this same condition violates, okay, then means if the value goes beyond 3 pu, if at any instant of time the estimator's value goes beyond 3 pu, then the violation would lead to bad data detection, and when this bad data detection is being made, so that bad data is rejected. Now the attackers, so if they compromise the measurements, that would get detected. So what they do is that the measurements would remain same, but the attack vector would be so designed in such a manner that this value won't go beyond pass beyond 3 per unit, but still the measurements or the V and delta would get compromised, because the V and delta we can see that if suppose this is the operating V, let's suppose, and this is the operating delta, any random values over the, this is the time axis, this is the time axis, this is the magnitude axis. Okay, this is V magnitude, this is delta. So if in a time frame, if such is the case, and we rely on these values, the outcome which is the outcome of this normalized test and WLS, that is the V and delta. So we would just see this V and delta, we don't have the information and we trust them, trust this WLS plus normalized residual test estimator. So whenever any attack vector is detected, attack vector, attack not attack vector, rather a bad measurement is detected, then that measurement will be rejected, and to some extent this would remain the same. But whenever any cyber attack is being done by any attacker, random attacker, so in those cases these values, this value would get compromised, this magnitude or phase angle, this value would get compromised. Suppose at any instant of time, let's suppose this value would become much smaller, or rather it would become, you know, different time frame. So what would be the outcome of this problem or issue? The outcome would be that if suppose if suppose this is the V that we consider, that we get after the attack is done, so V and delta gets compromised to an extent. Suppose this is the V that it should have been in the true operating case, and now this is the V that is that is the outcome of this estimation just because of the attack. So let's consider it as phasor. Both the magnitude and phase angle gets compromised. Let us consider. So the problem is that based on this, the power flow calculations would be made, and all these things would be made. And if we find that if the this is entirely an automated thing, so after this, if an after the entire this procedure, the power flows, all these things are calculated, and if it is found that the these limits are violated, now the breaker would trip, and when it is tripping, although it is in a healthy operating condition, the breaker is still tripping. So that leads to a very much problematic situation, and that would lead to some cascading failures. Okay, so that's the issue where we need to be careful while designing these estimators. So here it's the master station. So let's come back. This is the overview of how the problems, how what are the problems and how they need to be resolved in the design phase only. And these considers or test cases should be taken priorly to before being before being directly being implemented. Okay, so here we have the master station. We have the supervisory control actions where these actions like trip, close, this is the breaker circuit breaker status that we need to perform, whether we need to close or open, start, stop. These are the things from the master station. We deliver this information to the RTUs, and after that the RTUs deliver this information to through this analog output. Okay, and control of these two are analog outputs, and based on these information data to be transferred, these RTUs deliver the information using this path, the analog input output path. They take into action so as to deliver the information from the master station, right? So that's the basic overview. Now coming to the smart metering part. So mostly, if anybody has any idea of the smart metering, so they can just say something, because smart metering is a new concept. So any idea what are the smart meters and how they deliver the information to the substation or master station, distribution substation, etc. What are the advantages? Why are they being needed? What are the applications? With the smart meters being deployed, what are the advantages that we can get from the smart meters for better monitoring and control purposes? Any idea, if anybody can share? This is the basic block diagram. Means based on this, the smart meters, we can't, means this is the general block diagram. So any idea that how the smart meters perform? Anything? Why are they needed? Okay, so this is the smart meter signal acquisition part. Okay, so with this, smart meters allows the fundamental component. Okay, so fundamental component means the frequency, for fundamental frequency component. So after that, the this is the signal conditioning part. So we need to deliver the information only the fundamental component. So since the signal is mixed with various other third harmonics, other harmonic components, so we need to remove them, and for that filtering actions or signal conditioning needs to be done. This block is for that, and after that the analog and digital conversion is being done, and after that the computation and that data to be communicated to the master station. But what are the advantages? Now these smart meters, with the advent of these smart meters, we can get the information of the household voltage uh, measurements, how do voltage measurements. We can get the information of the power measurements. We can get the information of the frequency of operation. So we can also get the power profiles, that is the instantaneous power as well as the aggregated power also after also the month, that is for the billing purposes. Okay. The advantage of the smart metering is that they have removed the barrier of, means what previously things need to be done is that from the household side, the someone had to go to the household within the household premises, within the household premises and take the data, and then that data, this is, let's suppose this is the master station or the energy billing part, so there the data would be transferred, but here a human being was involved to, yes, the purpose of the smart metering. Okay, so main purpose of smart metering is that, yes, that is what I am telling, that the what smart metering concept leverage the problem of this human interaction, and suppose, and the human interaction was only for the billing purpose, so we only obtained the energy measurements, and that energy measurement which is accumulated over a month, only the monthly billing measurement that we would have obtained at the end of the month. But with the smart meters, we, what we have the option is that instantaneous, yes, this is the instantaneous measurements. And with these instantaneous measurements, now here comes a point that why, what are the advantages? So there are many advantages, out of which let me first indicate a basic advantage. We have the substation, okay, then we have primary transmission, then we have secondary transmission, then we have primary distribution, then we have secondary distribution, and these are the customer premises, means household. Anything we can consider, these are the household purposes, commercial, anything, means not only household. Let me just erase this term household. Commercial, residential, industrial. So from the industrial parts were mostly being taken from the primary distribution, because that would have involved mostly the measurements from, or some motors and all these things needs to be taken into action, because in the industry motors do work, so for that we need to take some small scale also from 33 kV, 11 kV, anything. And the secondary distribution, that is 400 site, that would be mostly the commercial, residential, and also commercial also can be in some cases taken from this, because some places they install their own transformers, so they take the data directly, or not the data, the line directly from the primary distribution outcome. So what I need to say is that in the primary context, means the previous context where the conventional power flow were there from top to bottom, so these smart metering concepts and all these things evolved after around, you can consider 2010. Okay, so some pilot projects are also being done, and here in IIT Kanpur also the pilot projects are as initiated by Government of India. So here in our campus we have around, and on average we can have around 60 smart meters. So based on that we have run a pilot project with the Government of India. And Kanpur is the IIT Kanpur is the only campus, an academic campus. Other pilot projects were there with the, means state distribution companies, state power distribution companies. So there were 12, 13 pilot projects being initiated from government, and out of which only academic institute was IIT Kanpur, where the pilot project ran, and out as an outcome, these details had to be submitted to the ministry, that why the distribution automation, that is a part of smart grid, why distribution automation is required in future. So for that, the smart meters played a very vital role. What are the actions? Like first of all, one thing needs to be kept in mind that how do I read smart meter? Means read in sense that you are willing to read in the customer premises, or you are willing to, means being a customer you are willing to read, or if you are willing to read as a distribution system operator, or you are willing to study about smart meter. Can you please clarify the question once? As a customer, okay. So as a customer, so it would be installed in your premises only. If you are willing to read, means go through the readings, so you can definitely get these readings from the smart meters, as well as these meters are also equipped with applications, means the apps, mobile apps, where we can you can get the idea of the energy usage pattern, instantaneous power flows, instantaneous power consumption profiles that you would get in your mobile or any app. Means mobile app mostly nowadays they are being installed in the Play Store app and all these things. So you can get the idea from the mobile itself that what are your energy consumption pattern, because don't need to see the meter for the energy consumption. Your billing would be given in the smart meter itself. Okay, so here you can see, means these are some tabs would be there. So if you can click that one day user profile pattern, 1 month user profile pattern, these points would be given, so you can read it from your mobile itself. Means this would be some softwares being previously you need to install a software which is associated with that company's uh, app, means company's meter. So after that your meter would be linked with that software, so that you can check your usage pattern in your mobile itself. Okay, so no need to check the meter for the readings. And also the operators won't come to your house, because they do have the information remotely. They are possessing your information remotely. Now here comes a big issue, a big challenge, that okay, let me go in a stage wise manner. What I was discussing is that your answer would be resolved. Means is this answer resolved? The other part, what are the applications, I would come within a few minutes only. Okay, okay, let's discuss. And if you have any further queries, you can write in the chat box, or you can ask directly, no issue. So what I was trying to tell is that the previous concept of a single master substation or master station, that is NLDC, was there, and some intermediate substations were there in the transmission side only to monitor the transmission system. But with the advent of the distribution system automation, nowadays distribution system operators, this was the report that was submitted by the project, the smart grid pilot project, that was initiated by IIT Kanpur, IIT Delhi, and PERI, the Engineering Research Institute, that is also in Delhi. So they submitted a report in 8th May, I mean submitted before, which was published on 8th May 2023. That what is the need of, you can check this report, you can get this report if you search in the internet. So there you would get that what is the need for DSO. This, so the transmission system operator model was initially there. Okay, in the power system only transmission system operator model, means TSO, that is the power grid POSOCO, means the POSOCO were the transmission system operators. But Just we in a year time frame, the DSO model has been proposed, and the report has been submitted and it has been published and published for publicly. It is accessible. So there we can get the information why the distribution system operators is needed and how are the smart meters playing their part in the distribution system automation and control. So what the information is delivered by the, what are the information, the information of the power measurements, instantaneous power measurements. So last day, if anybody were there in the last day, so one or two points that I've discussed, because how the means for today, means if let's consider the case that today we are willing to perform the load forecasts of the next day. So we do have the information of the entire next day load forecast, right? So okay, let me go to a fresh page so that so suppose we are today is Saturday, right? Today is Saturday. Okay. So on Saturday we have a entire report of how Sunday would be operating, means consisting, we would be focusing mostly on the power system context. So the entire 24 hours is divided into 15 minutes, 15 minutes slab. Okay, so per 15 minutes there would be the power profiles to be changed for each and every generator, load, etc. Means based on load the generator profiles would be scheduled. And what are the parameters that we need to take into consideration is that, suppose we have the information, what we can do is that stand on today we can do a load forecast. Okay, load forecast for tomorrow. So once we have the load forecast for tomorrow, because load forecast is a action which is done by each and every system operator. Now first stage is load forecast. Based on this load forecast, what we need to perform is that unit commitment and economic load dispatch. So first unit commitment, when the units are committed, which unit would deliver this load for each 15 minutes slab I am talking about. So after unit commitment we would be doing economic load dispatch. So when once the unit commitment results are 1 or 0, means digital results, that this unit should be on or this unit should be off. And after that we have the information of, we will need to perform the economic load dispatch. So what is economic load dispatch? Now for, let's suppose there were total of 50 units, and out of those 50 units after unit commitment it came as an information that only 37 units would run for that 15 minutes of time. So out of now these 37 units, which unit would deliver which amount of power, means load demand. Let's suppose if during these 15 minutes of time a load demand of 100 megawatt is there. So which generator would deliver which amount of, means which share of this 100 megawatt, because all the generators are not of the same capacity, right? So what we need to do is that this economic load dispatch is done. So now the values we have obtained, and after these things we perform load flow. So based on this load flow we check that whether, means all these things are within, all the power flows and all these conditions are within limit, constraints are within limit or not. If it is there, then it's fine. So this was the standard operating principle that is being done for the last, means previous operational principle is this one for the transmission side. Now I have used this term load forecast. So what do you think this load forecast uh, do involve, means what are the, what is the, let me frame the question like this, that what do you think that these load forecasts, what are the things being taken into action before as an outcome of load forecast, and what are the, suppose we are getting the load forecast as for today, but what is the basis of this forecast, means what are the information we are giving to so as to get a forecast for this time frame, for this day? Any idea? Any idea? Just random guesses you can make, or if you know the answer, then it's definitely good. And who is involved in this involvement? Who are the uh, means, let's consider, means it's not a basic individual, but as a whole, as a unit, which unit is mostly involved in giving this outcome of this load forecast? Any guesses? Any idea? You can write, or you can any random. Just now I have discussed also based on the discussion that being made on 5 minutes before, 5 minutes earlier. Okay, so okay then. So load forecasts, mostly the load forecasts involve the information of the previous day load consumption or power consumption, right? So suppose we are willing to get the load forecast for day, let's suppose day P. So for that, we need to deliver the information of the loads or the usage patterns for the last P minus 1 days, so as to get a information of that pth day. So what are these usage patterns? Means what are the what we need to forecast? We need to forecast real and reactive power. So mostly the real power is the load demand. So if we need to find out the real power, so for that we need to have the information of that real power, and who will give that information? In the previous context, we used that energy profile, that billing person, what I have mentioned earlier also, that a billing person used to go to the area. Yes, a billing person is involved to collect the data from the area, and based on that, the data is being given or stored uh, in the substation or the automation section part. So based on that, that data is shared so as to perform the load profile of each area. Now he collects the data of an area. So area 1, area 2, if we go on like this, so that would accumulate to a bigger area. Now another person is doing another area. In this way, this bigger spectrum would be covered, and based on this is the locality. Let's suppose this is the locality, and after that this is the township, this is the, let's consider accumulating these two would result in a uh, entire city, then accumulating more cities that would result in a entire district, and all these things. Okay, so based on that, what we obtain is the load demand of those areas, and based on these load demands, and what are these are the energy consumption, that from energy consumption we can get the power consumption. Okay, but that's the advantage that this was the case for the TSO model, transmission system operator model was there. So these were working fine, this system was working fine. But now with the advent of distribution system operators and with the smart grid concept, the enablers of the smart grid concept, that is the distribution side, this part of smart metering got the most priority, because that energy consumption pattern was the averaged energy of the entire month. So granular load power forecast. wouldn't was not possible, would not have been possible if we don't integrate a faster acting device. Although the PMUs, RTUs, any idea how what is the refresh rate or data refresh rate of the PMUs, because it was there in the lecture, and last day also I have discussed. So any idea of how what is the refresh rate of the PMUs, general transmission system PMUs, or and the RTUs, remote terminal units, in what refresh rate do they deliver data to the information to the master station? Any idea? You can speak up, or you can write in the chat box also, no issue. Because that's the interesting part. Because if we do a comparative study, then that would deliver the importance of how each and every system, evolution of each and every system is gaining the or aiding in the present day smart grid context. Any idea? Any just you can. About the frequency of PMU? No, not about the frequency of PMU. Frequency is the measurement that we obtain from a PMU, frequency, rate of change of frequency. But I am telling that what is the refresh rate, means the sampling rate of the PMUs, of each and every sampling rate, means PMU sample at some refresh rate. So what is that refresh rate? Any idea? Means PMU sample at a prescribed sampling rate, standard. It has now been standard, but it can do much faster also if we program it that way. But for the time being, that some basic standard sampling rates are being chosen. Means the some rate of data arrival to the control center from a PMU, from RTU, IEDs. RTU you can consider IEDs also. It was there in this lecture also. Just any random guess. So that means the context of uh, rate of 45 or 48 unit. So unit, if I consider that 45 or 48 is a bit faster, not bit faster, it's within range also. But what's the what why 45 and 48? Because yes, yes, okay, no issue. If the PMUs deliver information samples per cycle, okay, but PMU delivers information of 25 uh, 25 frames per second to 50 frames per second. Somewhere it is 25, considered as 25, somewhere 50, but it can be programmed in between. But general consideration is that 50 frames per second. Okay, so and RTUs, any idea? RTUs for the RTUs, it's for the RTUs, it's 2 to 5. Per 2 to 5 seconds, we have one data. Means each and every RTU can report a data to the control center after 2 to 5 seconds. Okay, so now coming to the smart meters, why we were discussing the importance of smart metering in the present context. So why the smart meters, with the smart meters the refresh rate is somewhere, we can program it in a in various fashion, but mostly it is considered 5, 15, 30, and 1 hour, and these are in minutes. So now here comes a question that we are fetching information in seconds, or within 1 second we are fetching information 25 times, 50 times. Now why are we using or why are we fetching information in 5, 15 or 30 minutes, 1 hour? Why a slow rate? Why such a slow rate is being considered? Here comes a question. So the thing is that the smart meters deliver the information in this rate. Now previously it is in a budding stage. Okay, so since the smart meters are in a budding stage, we need to develop uh, that storage system needs to be, facilities needs to be developed on a much larger scale. And with such a large number of smart meters being deployed on each and every household or each and every industry, just guess the amount of data that we would be getting if we have kept it at a refresh rate of 5 seconds. And the other thing is that, so if we consider for a single household, let's suppose household 1 or industry 1, let's consider for household 1. Okay, let me just show you a basic distribution system, just a radial distribution system, a single line diagram, and a balanced one. Although it is an unbalanced system, it mostly is unbalanced system, but for a general discussion purpose, just to give an overview, let's consider this is the 33 by 11 kV substation, that is HV substation. Okay, HV substation, and these buses are the nodes are the MVLV nodes, all these nodes. Okay, so what I am willing to say is that, and these are the loads. So we are mostly concerned about, here we have a substation, that is a transformer, pole mounted transformer, where you have seen in your residential areas, also in your localities, that an NVLV substation, that is transforming it is into 11 kV to 400 volt three phase, and from that we, for each and every household, it is 230 volt single phase, and for the commercial purposes they do take in three phase, and after that they distribute. So that's a different case, but what I am trying to say is that now with the smart meters are being deployed at each and every household, so it is beyond this MVLV substation, means it is on the LV side. Okay, so we are on the LV side now. For each and every household, we don't need to take that information into account. Yes, that is required whenever the customer size or customer uh, means the power consumption by the customer is quite big, now quite high. So in the present context, what we can say is that the NVLV substation that we have, here we have a locality, here we have another locality, and here we have another locality. Okay, let's area 1, area 2, area 3. So these three, based on these areas, we have various smart meters being offered each and every household in this area 1. Now we just need to have the information of the accumulated power consumption at this node only, at this node, so as to those accumulated, so as to get the information of that, of these accumulated node at these substation bus. So based on these power profiles being accumulated here, we get the information. We just take the information, because here the operating personnel is mostly, because DSO substation operational unit is here at the substation, at the distribution system, where from where the primary distribution is starting. Okay, there the distribution system sub automation or distribution system operator is present. So they are mostly concerned about what needs to be done at this point, and what is needs to be done at this point is dependent upon all these points. And if we can aggregate them into this point, then we are aware of what needs to be done beyond that. So if we do take care of this information of just this point, we are aware of all these things present here. So that's the major uh, advantage of this smart meter, that these smart meters are being deployed area wise and each and every household, commercial buildings, anything, and they are delivering the information so as to get an accumulated information on a much faster time scale. So previously what were there is we get the information, accumulated information at this node, and that was also collected by the transmission system operators at each, for each month, that is monthly data. Now what we have is that every 5-minute data, or if we let's consider standard case 15-minute or 30-minute. So considering to monthly data, you can just observe what how much these refresh rates are more. So the accuracy of load forecasting would get enhanced with the integration of the smart meters in the power system. So this is the one of the major advantage of smart meters being deployed in the distribution side. So my question was there that what was the advantages of this becomes major advantage, and if we can do the load forecasting more accurately, because when we use the term forecasting, that itself comes with the error being associated, because forecast can't be true, means there will always be an error associated with it. Okay, so if we were willing to minimize that error, we are willing to minimize that error. So if the error will definitely get minimized when when we were using this monthly data as the load forecasting to data to do load forecasting, and whenever we are using this 30 minutes data or 1 hour data also. So that would also give a much higher refresh rate, because 1 hour means 24 into 30. So these many amount of data samples get uh, incorporated. So that increases the efficiency of load forecasting, and that load forecasting is very much important for performing the economic load dispatch, because based on this load forecast, firstly load forecasting is done. Based on this load forecast means what's your need, the consumers are given their need, and based on that need the generators would participate accordingly, because that much need they have to fulfill. Okay, so based on the load forecast, if this is highly accurate, and this is depending upon the smart meters to a huge extent. If you can deploy the smart meters all throughout our country, that would make enhance the entire operation of the system to a much larger scale, right? So load forecasting gets enhanced. With that, the economic load dispatch or unit commitment and economic load dispatch both get enhanced, because suppose previously the load forecast at a point of, let's consider for a point of time 500 megawatt, sorry 500, let's consider 50 megawatt. 500 megawatt is not the, yes, 550 megawatt, let's consider 50 megawatt at a point of time at an area, it's a random choice. So for that, if load forecasting was wrong, means let's suppose the true load demand is 45 megawatt, and with the smart meters it is 50 megawatt, and with the monthly load pattern it's 60 megawatt. So here also 5 megawatt error is there, but here 15 megawatt error is there compared to this. So the issue that is getting resolved is that we don't need to, suppose for that 15 megawatt a different generator needs to be switched on, because the unit commitment problem would change, and the different generator, a single unit would have been required to get switched on to deliver that, to cater that load demand. So that is itself a challenging task, because that would incur some cost, and we are aiming to minimize the cost. So that's the aim, or that's the advantage, how the smart metering is helping in the uh, overall operational enhancement of the, we can minimize the cost with such a faster rate. And we can sample, we can program the smart meters on 1 second also, but we need to have that data being stored. So, and the user profiles, per user profile seconds rate of data is not at all required, because that 5 minutes data is enough for a household purpose. But there are aspects where yeah. ओके, ठीक है, ठीक है, तो सो ठीक है, ठीक है, तो अब तक मतलब आपको क्या प्रॉब्लम हो रहा है, मतलब आपको ये समझ में आया कि हमने क्या बताया, ये जो एडवांटेज ऑफ स्मार्ट मीटरिंग जो अभी डिस्कस कर रहे हैं, तो इसमें कैसे जो स्मार्ट मीटर्स हम लोग डिप्लॉय किए हैं और इनका जो रेट ऑफ डेटा एक्विजिशन है, तो इसका एडवांटेज आपको समझ में आया है कि कैसे हमारे लोड फोरकास्टिंग पे इकोनॉमिक लोड डिस्पैच कम होने से क्या क्या हम लोग को इन द कॉन्टेक्स्ट ऑफ हम लोग को जो है पैसा, जी, कि हम लोग का तो कॉस्ट मिनिमाइज करना है कैसे भी करके, हमको खर्चा मिनिमाइज करना है टोटल पावर सिस्टम ओवरऑल अगर देखा जाए तो। मीन्स ये आपको इसमें कोई दिक्कत है, मतलब इसमें समझने में कुछ दिक्कत आया सर? एक बार आप एक बार वेरीफाई कर दीजिए, अब अभी से हम वही दोनों ईएमआई बोल देंगे, बट फॉर द टाइम भी अभी तो इतना बोल दिए है, तो ठीक है, ठीक है, ठीक, ओके। So, I'll converse both in English as well as Hindi, so as for a better understanding for all. Okay. So for the time being, this was one of the issue that got resolved. Now अदर जो पार्ट है वो क्या है, इसको कहते हैं हम लोग नॉन इंट्रूसिव लोड मॉनिटरिंग। ठीक है, किसी को आइडिया है? डू एनीबॉडी हैव एनी आइडिया ऑफ व्हाट इज नॉन इंट्रूसिव लोड मॉनिटरिंग? ये स्मार्ट मीटर, दिस इज अ पार्ट ऑफ स्मार्ट मीटरिंग कंसेप्ट, तो एडवांटेज ये स्मार्ट मीटर के साइड पे ही हो रहा है। So anybody have any idea that what the smart meters are giving advantage to? हाँ, आपके लिए हिंदी में भी हम बोल दे रहे हैं कि इसका एडवांटेज क्या है, मतलब आपको कोई आइडिया है कि नॉन इंट्रूसिव लोड मॉनिटरिंग के लिए हमारा स्मार्ट मीटर्स कैसे हेल्प करते हैं? कोई आइडिया और एनी आइडिया ऑफ दिस टर्म इटसेल्फ किसी ने सुना है? Did anybody? No idea. Okay, okay, okay. So this concept of okay, okay. So non-intrusive load monitoring से क्या होता है? The main advantage of non-intrusive load monitoring is that, okay, let me first say this is the, suppose a customer load profile or you know customer usage profile. Okay, so this is the power consumption profile for a customer, ये एक कस्टमर का पावर कंजम्पशन प्रोफाइल है। सो लेट सपोज ये जो डेटा है ये स्मार्ट मीटर को बहुत फास्टर रिफ्रेश रेट से लिया गया है। ठीक है, लेट सपोज इसका रिफ्रेश रेट है 1 second, so we have collected this data per second, so for the time being let's consider that the smart meters are so programmed so as to deliver the data in 1 second per second, right? So 1 second में data दे रहा है, so what we get is that a faster refresh rate and a better picture or granularity of this entire data consumption profile is much more. Okay, इसका data granularity ज़्यादा है। So the advantage is that, or from this smart meter is that we need to classify the problem. We need to classify the problem, and based on this classification, we get the idea that what are the equipments, क्या क्या equipments हम लोग चला रहे हैं इसमें। ठीक है, तो सपोज ये प्रोफाइल से हमको आइडिया लग जाएगा ये एग्रीगेटेड प्रोफाइल है जो मीटर में मिल रहा है, ठीक है। ये एग्रीगेटेड प्रोफाइल से हमको आइडिया मिल जाएगा कि घर में व्हाट इज द टाइम, व्हाट इज द टाइम for how, or rather I would say for how much time refrigerator was being installed. Refrigerator was not installed, rather I would say a refrigerator was switched on what was the time frame when the event has occurred. So हम लोग को डिटेक्ट करना है क्या इवेंट हो रहा है। सो इससे क्या है, स्मार्ट मीटर से हमको कौन सा इक्विपमेंट कौन सा टाइम में चलाना है और कितना टाइम चल रहा है, क्योंकि द ओवरऑल पावर प्रोफाइल, डू एनीबडी हैव आइडिया कि पावर प्रोफाइल हम लोग का ओवरऑल अगर दिखा जाए तो कैसा होता है? व्हाट इज द जेनेरिक पावर प्रोफाइल, पावर कंजम्पशन प्रोफाइल ऑल थ्रू द डे फॉर द एंटायर कंट्री, generic entire country if we say. So it is like a, this is also called a duck curve. You would come to know about these things in the later part of these lecture series. Okay, so इसमें क्या है कि ये है मॉर्निंग पीक, ये है इवनिंग पीक। सो इसके बिटवीन ये एक वैली है, ठीक है। इधर क्या है, यू हैव अ वैली हियर। सो अगर हमको देखा जाए कि अगर इस वैली को फिल कर पाएंगे और इधर से थोड़ा कट आउट कर सकेंगे, so that would lead to a overall system, means the profile can be made even flatter, and that's our aim कि to maintain constantly एक ही प्रोफाइल पे हम लोग चलाए, ठीक है। बट प्रैक्टिकली दिस इज नॉट द केस। सो प्रैक्टिकली इधर ये थोड़ा गड़बड़ हो रहा है। इधर क्या आ रहा है, इधर वैली हो जा रहा है, इधर पीक हो जा रहा है। तो हमको वैली को फिल करना है और पीक को कट करना है। सो फॉर दैट ये जो एम है, इसमें हम लोग क्या करते हैं, नया नया स्कीम्स चालू हुआ है कि डिमांड रेस्पॉन्स। डू एनीबडी हैव एनी आइडिया व्हाट इज डिमांड रेस्पॉन्स स्कीम फॉर पावर सिस्टम? एनीबडी? ओनली टू आर देयर, सो you can write in the chat box or speak up also, no issue. Any demand response scheme comfortable in Hindi or English, आप जिसमें बात करना चाहते हैं कर सकते हैं, कोई बात नहीं। Any idea of demand response? क्योंकि प्रीवियसली ये जो बात किया हमने ग्रैनुलरिटी, इससे हम लोग को पता चल रहा है कितना टाइम तक फ्रिज चल रहा है, कितना टाइम तक एसी चल रहा है, कितना हेवी लोड्स, कितना टाइम तक हीटर चल रहा है। सो इससे आपको पता लगेगा कि कौन सा ह्यूमन बीइंग और कौन सा हाउस होल्ड कितना टाइम में क्या क्या चलाता है। तो एनी आइडिया कि इसमें डिमांड रेस्पॉन्स का कोई बारे में कोई आइडिया है आप लोगों को? एनी आइडिया ऑफ डिमांड रेस्पॉन्स? यू कैन चैट, टाइप इन द चैट बॉक्स। और अगर नहीं है तो हम ये कर देंगे, डिटेल कर देंगे, बट डिस्कशन के फ्रेम में होगा ना, तो यू गेट बेटर अंडरस्टैंडिंग। Okay, okay, no. So demand response is a program where we need to suppose all the people are switching on their AC during this morning peak. So it after performing based on the smart meter data, what we can observe that whether or not क्या पूरा एरिया में all the people who are staying in that area or in that locality are switching on their AC or fridge or heavy load, means heavy equipments जिसका पावर कंजम्पशन ज्यादा है, वो इसी टाइम पे ही कुछ चला रहा है कि नहीं चला रहा है, इसका आइडिया हम लोग को लगेगा। और उसके बेसिस पे हम लोग क्या करेंगे, जो डिस्ट्रीब्यूशन सिस्टम ऑपरेटर है ये लोग क्या करेंगे, ये लोग इन लोगों को इंसेंटिवाइज करेंगे, ठीक है। इंसेंटिवाइज करेंगे कि आप अगर इफ यू कैन रिड्यूस योर पावर कंजम्पशन और यू कैन स्विच ऑन योर एसी ड्यूरिंग दीज आवर्स, इसके बीच में जिसमें वैली है, इसमें अगर स्विच ऑन करे तो आपका जो पावर कंजम्पशन रेट है वो अगर इसमें आपको 12 रुपया करके ले जा रहा है तो इसमें आपको 7 रुपया करके लिया जाएगा. तो each and every person or the household would get a motivation that if we do perform this kind of activity or if we do reduce or curtail our loads, because why it is needed, the major challenge is that if we can maintain a flatter profile like this one, that would give a good understanding to the power system operators to maintain a even management of the generator switching on and switching off. But here more number of generators to be switched on and after that a large number of generators to be switched off and then again on. So here is a disparity is being there. Constantly a अप एंड डाउन हो रहा है ऑफ जनरेटर स्विचिंग ऑन एंड स्विचिंग ऑफ. सो उसके बेसिस पे आपको इंसेंटिवाइज किया जा रहा है कि अगर आप लोग अगर इसमें एसी चलाएंगे तो पैसा कम लेगा. तो जो मोटिवेटेड कस्टमर्स होगा, जिसका जो कस्टमर्स हु आर हाईली मोटिवेटेड, दे वुड डू दैट सेम. आपको ये बोल दिया कि ईवी चार्जिंग करो, हाँ ईवी लोड भी आता है, ईवी घर में ईवी चार्ज कर रहा है इलेक्ट्रिक व्हीकल, तो ईवी लोड को आपको बोला गया कि इसमें चार्ज करो तो आपको कम पैसा लिया जाएगा. तो आप मोटिवेटेड है, हम लोग भी मोटिवेटेड हो जा रहे हैं. सो वी आर गेटिंग मोटिवेटेड टू चार्ज द ईवी विद इन दिस टाइम फ्रेम, मीन्स दिस पीरियड ऑफ टाइम. सो क्या, तो ये अगर ज्यादा से ज्यादा कस्टमर किया जाएगा तो क्या होगा, ये वाला पार्ट से घट के ये वाला पार्ट भरेगा, थोड़ा थोड़ा करके भरेगा. सो दैट्स आर एम. सो दिस इज नोन एज डिमांड रिस्पॉन्स प्रोग्राम. बट फॉर डिमांड रिस्पॉन्स प्रोग्राम पहले आपको तो पता होना चाहिए कि कौन सा कस्टमर क्या क्या चीजें ज्यादा यूज कर रहा है. तो उसको आपको वो जो सॉफ्टवेयर एप्लीकेशन है वो एप्लीकेशन में आप उनको नोटिफाई करेंगे कि आप इसका यूसेज कंट्रोल कर सकते हैं. कैसे कर सकते हैं, आपको ये ऑफर दिया जा रहा है. सो दीज आर सम डिमांड रिस्पॉन्स प्रोग्राम्स दैट नीड्स टू बी, क्योंकि हमारा एम है कि कंटिन्यूअस पावर फ्लो. आप हमारा एम, आर एम इज टू मेंटेन continuity in power flow, not to interrupt the power flow in a locality. Okay, so for that demand response programs do play a much larger part. So now you can ask me why the term intrusive. Intrusive, what is the meaning of intrusive? कि आप किसी का कस्टमर का प्राइवेट यूसेज पैटर्न पे आप इन्वेट कर रहे हो. बीइंग अ डिस्ट्रीब्यूशन सिस्टम ऑपरेटर, आप उनका ऑपरेशनल टाइम फ्रेम पता करके, क्योंकि आप तो ऑपरेटर है, आपके पास सब डेटा आ रहा है कौन सा मीटर से, तो कौन सा कस्टमर उस टाइम पे घर पे है नहीं है, क्योंकि if their power consumption is zero, then they are not in the house or for a longer time frame. Okay, so what we need to do is that, क्योंकि if someone is staying in the house and not switching any of the devices, कोई कुछ भी नहीं चला रहा है, ऐसा होता नहीं है जनरल पर्पस में. तो अब now you can question that someone can means the operators can be involved in with the thieves and they can send the information to them theft activities so that theft activities can be performed because no one is staying inside. So for that this is intrusive, but this one is non-intrusive. So how non-intrusive is getting enhanced? So some blockchain technologies are being there. Key, the answer is random, means you won't get the information of the exact household, but the information from that household would, let's suppose ये है household 1, household 2, household 3 etc. ओके, और इधर आपका है कि डेटा सेंटर में डेटा पहुंच रहा है, आपको H1 का डेटा इधर जा रहा है लेकिन आपको पता नहीं है कि H1 का डेटा है, और आप जो आंसर दे रहा है ये भी डेटा आपको H1 पे ही चला जाएगा, लेकिन आपको पता नहीं है कि वो H1 पे ही जा रहा है. आपको यही है मतलब ब्लॉकचेन टेक्नोलॉजीज का एडवांटेज, जिस पे काम हो रहा है, एकदम नया मॉडल है, तो इसके बेसिस पे अभी काम चल रहा है. ओके, so that's some of the applications. So someone questioned that what are the applications of the smart meters, and I questioned one. So based on that, if someone has any further doubt they can ask. So some of these activities are like load forecasting getting enhanced, demand response programs being enabled, non-intrusive load monitoring being performed. So everything is involved with the smart meter. So that justifies the application or the uh, justifies the usability of these smart meters. Okay, so any queries or any questions or any clarity that you have received, आपको सुन के ये लगा कि इससे अच्छा मतलब ये आइडिया क्लियर हुआ आपका कि क्या क्या स्मार्ट मीटर का एप्लीकेशंस हो रहा है और एनी queries that you want to ask or then we'll just give a brief overview and we'll discuss some questions that uh, that is already been there.
Hello,
हाँ हेलो.
I have one question. ये जो डिमांड रिस्पॉन्स है, ये जो स्कीम है, इसके
हाँ,
अंदर ये भी पता जो इम्प्लीमेंट हो रहा है, इसके अंदर ये भी पता चलेगा कि जो कस्टमर है क्या ईवी चार्ज कर रहा है या फिर हीटर लगा रहा है, ये इक्विपमेंट कौन सा यूज कर रहा है, ये भी पता चलेगा तो इसमें।
ये पता चलेगा आपको नॉन इंट्रूसिव लोड मॉनिटरिंग इससे पता चलेगा, ठीक है। तो ये इसके बाद ही कर सकते हैं। ये नॉन इंट्रूसिव लोड मॉनिटरिंग में आपको क्या है कि आपका एग्रीगेटेड जैसे हमने बताया, ये है एग्रीगेटेड यूजर प्रोफाइल मीन्स एग्रीगेटेड पावर कंजम्पशन प्रोफाइल ऑफ अ डे, एक दिन का मान लीजिए, ठीक है। तो एक दिन का पूरा पावर प्रोफाइल के बेसिस पे ये क्लासिफिकेशन प्रॉब्लम है जिससे आपको बहुत सारा डेटा एनालिसिस डेटा मशीन लर्निंग स्कीम्स इन्वॉल्व है, बहुत सारा काम हो रहा है, एकदम नया चालू हुआ है 2015 या 2018 के बाद से ये हाइप में आया है कि बहुत सारा काम हो रहा है किसमें हाउ टू एक्यूरेटली डिटेक्ट क्या क्या मतलब डिटेक्ट बेस्ड ऑन क्या है इवेंट। सो इवेंट क्या है मतलब सपोज आपका लोड प्रोफाइल ऐसा चल रहा है, सडनली एक स्पाइक आया, तो वो मतलब कुछ इवेंट हुआ है, क्योंकि जैसे ही आप कुछ एसी मोटर जैसे कि आपका इंडक्शन मोटर होगा, आप चलाएंगे, आप वाटर जो पंप है जिसमें पंप करके पानी उठाता है, इसमें माने रिजर्वर में आपका ये पानी उठाते हैं, तो उसमें आपको क्या होगा जैसे ही मोटर इनिशियली स्टार्ट होता है उसमें आपको इवेंट डिटेक्ट होगा क्योंकि उस टाइम पावर फैक्टर लो रहता है, इंडक्शन मशीन है। तो इसके बेसिस पे जैसे ही आप डिटेक्ट होगा तो ज्यादा पावर करंट कंजम्पशन होगा इनिशियल जस्ट ऑपरेटिंग टाइम में, जस्ट इनिशिएशन टाइम में। और जैसे ही ये डिटेक्ट होगा इवेंट, उसके बेसिस पे उसका प्रोफाइल डिटेक्ट होता रहेगा, और जैसे कितना देर तक अब फिर बंद करने के टाइम पे भी वो इवेंट होगा। अब ये इवेंट के बेसिस पे ये पता चलता है कि जैसे एक होता है पीक लोड, एक होता है बेस लोड। जैसे बेस लोड में तो चल रहा है उसको लेकर कोई इतना चिंतित नहीं है, लेकिन जैसे ये इवेंट्स आता रहेगा, कुछ कुछ इवेंट्स आता रहेगा, वो थ्रेशोल्ड वैल्यू से जैसे ही बढ़ा जाएगा तो ये इवेंट डिटेक्ट होता रहेगा, और ये इवेंट्स का और इसके बेसिस पे जो इसके बीच का जो प्रोफाइल है ये इवेंट चलेगा भी ऊपर से, क्योंकि बेस में तो आपका फैन लाइट ऐसे ही चलेगा। तो उसके बेसिस पे अब ये क्लासिफाई करेगा कि रेफ्रिजरेटर जब ऑन ऑफ होगा उसका एक कुछ एग्जैक्ट पैटर्न होगा। अब ईवी इलेक्ट्रिक व्हीकल का पैटर्न अलग होगा, प्रोफाइल मीन्स पावर कंजम्पशन प्रोफाइल, एसी का अलग होगा, हीटर का अलग होगा। तो इसके बेसिस पे आपको आइडिया लगेगा कि कौन सा चल रहा है। तो ये बेस्ड ऑन दिस प्रोफाइल ये लोड मॉनिटरिंग एक्शन के आउटपुट में आपको बोला जाएगा कि इतना टाइम से इतना टाइम रेफ्रिजरेटर चला है, एक्यूरेटली डिटेक्ट करेगा कि रेफ्रिजरेटर चला है, इलेक्ट्रिक व्हीकल इतना टाइम से इतना टाइम चार्ज हुआ है, क्योंकि इसका डेटाबेस में बहुत सारा प्रोफाइल्स ऑलरेडी एग्रीगेटेड किया जाता है, और इससे वो कंपेयर एग्जैक्ट तो नहीं होगा क्योंकि आपका इलेक्ट्रिक व्हीकल सपोज टाटा का होगा और दूसरे का इलेक्ट्रिक व्हीकल सपोज मारुति सुजुकी का होगा, लेट सपोज, मतलब हम एग्जैक्ट नहीं बता रहे। तो इसके बेसिस पे दोनों का प्रोफाइल डिफरेंट तो होगा, बट इलेक्ट्रिक व्हीकल का प्रोफाइल रेफ्रिजरेटर से कभी नहीं मैच करेगा। तो इसके बेसिस पे ये डिसीजन में आता है, और ये लॉट ऑफ स्टेजेस होता है जिसमें रिसर्च एक्टिविटीज आर गोइंग ऑन। तो इसके बेसिस पे ये पहले क्लासिफाई करेगा कि क्या क्या चला रहा है। अब इसके बाद वो डिमांड रिस्पॉन्स मैनेजमेंट में, क्योंकि ये सब डेटा आ गया इसके पास, ये ऑपरेटर्स के पास, अब ये क्या करेगा एज ए पार्ट ऑफ डिमांड रिस्पॉन्स प्रोग्राम, ये डिलीवर करेगा उन उन कस्टमर्स को कि आपका यूजर प्रोफाइल में आप इतना टाइम से सुबह मतलब सुबह ही आपने ईवी चार्ज कर दिया जिसमें और भी लोड हाई था, मतलब मॉर्निंग पीक में पीक था और पीक आपने बढ़ाया, तो आपको नेक्स्ट दिन से के लिए अलर्ट कर दिया गया कि आप इस टाइम की जगह अगर इस टाइम में यूज करेंगे तो आपको 7 रुपया देना पड़ेगा, और इस टाइम में जगह आप मॉर्निंग में यूज करेंगे तो आपको 12 रुपया देना पड़ेगा। तो दैट मीन्स आपको पेनल्टी भी लग रहा है अगर आप यूज करेंगे, बट आपको पहले से बता दिया जा रहा है, तो आपको उसके बेसिस पे आपको पहले से प्लान कर लेना पड़ेगा, ताकि क्योंकि हम लोग ओवरऑल वी आर ट्राइंग टू रिड्यूस द ग्लोबल कार्बन फुटप्रिंट। तो इसमें अगर इसका वेरिएबिलिटी ज्यादा रहेगा, तो मोस्टली वी आर एमिंग टू इंटीग्रेट द रिन्यूएबल्स इन द सिस्टम। सो हम अगर रिन्यूएबल्स को ज्यादा से ज्यादा इंटीग्रेट करना चाह रहे हैं, तो रिन्यूएबल में दिक्कत यही है कि रिन्यूएबल जितना देगा उतना ही हमको लेना पड़ेगा। रिन्यूएबल को हम डिमांड नहीं कर सकते कि इतना हमें चाहिए। तो रिन्यूएबल्स को छोड़कर जो बाकी डिमांड होता है, वो डिमांड हम लोग थर्मल से लेते हैं, हाइड्रो से लेते हैं। फास्ट एक्टिंग चाहिए, सपोज किसी आउटेज हो गया, तो ये सब करते हैं। पावर पंप स्टोरेज प्लांट से लेते हैं। तो मेनली क्या है, तो डिमांड रिस्पॉन्स करके हम लोग प्रोफाइल को फ्लैटर कर सकते हैं, जिसमें ये एब्सर्ड कंडीशंस की, ये सडनली इससे चाहिए जल्दी जल्दी इनको स्विच ऑन करना बोलो, ये स्विच ऑफ करना बोलो, ऐसा मतलब जो हम लोग एंसिलरी सर्विसेज को ज्यादा यूज मत करना, हम लोग का एम रहेगा। एंसिलरी सर्विसेज क्या होता है कि बैकअप आपका सपोर्ट के लिए, आपका जनरेटर 100 मेगावाट मैक्सिमम डिलीवरिंग कैपेसिटी है, आप जनरेटर को ऑन रखे हैं कि लेकिन अपने 50 मेगावाट पे चला रहा है, तो अभी भी वो 50 मेगावाट देने के लिए तैयार है, उसके पास एबंडेंट स्पेस है 50 मेगावाट। लेकिन यही अगर आप इतना एक्यूरेट अगर फोरकास्ट कर पाएंगे, तो अगर इस 50 वाट को दूसरे जनरेटर पे थोड़ा से थोड़ा करके, अगर सब जनरेटर तो फुल लोड पे चलता नहीं है, तो अगर एक जनरेटर भी आप स्विच ऑफ कर पाए, तो उसके लिए जो कॉस्ट इन्वॉल्व होगा वो भी बहुत सारा पैसा बचा सकते हैं। सो दैट्स द एम ऑफ दिस डिमांड रेस्पॉन्स एक्टिविटीज, टू रिड्यूस द ग्लोबल कार्बन फुटप्रिंट, राइट। तो ये मतलब आपको अगर एनी क्वेरीज है तो आप कह सकते हैं।
Immortality.
ठीक, ओके, थैंक यू। और ठीक है, तो where स्मार्ट मीटर मेल फंक्शंस, डेटा एक्यूरेसी, यस, ये तो है। ये तो ये मेल फंक्शन तो इसमें होता ही है, मतलब इसमें जैसे स्मार्ट मीटर का कुछ इश्यूज होता है कि कभी कभी ये रिपोर्ट नहीं करता है, ठीक है। तो जैसे हम लोग भी ऑब्जर्व किए हैं कि जैसे कुछ कम्युनिकेशन प्रोटोकॉल्स होता है, जिसमें एक होता है इसका मेल फंक्शन का बहुत सारा टाइप्स है, कि एक कम्युनिकेट ही नहीं किया, एक किया कम्युनिकेट किया लेकिन गलत डेटा दे रहा है, ठीक है। तो इसके लिए आपको कॉन्स्टेंटली मॉनिटर करना पड़ेगा। और एक्यूरेसी, जितना तक कह पा रहा हूँ कि आपको एक्यूरेसी मेंटेन करने के लिए कुछ अलग तो प्रेजेंटली नहीं इन्वॉल्व किया जाता है कि आप स्मार्ट मीटर एक्यूरेटली, लेकिन वही यार क्या कि आपको रेगुलर चेकअप करना पड़ेगा, मॉनिटरिंग करना पड़ेगा कि अभी ठीक दे रहा है कि नहीं दे रहा है। और as far as the estimation part is concerned, if you have the idea of how the estimation part is concerned, so for that the estimation results would deteriorate. Okay, so one thing is that a term called redundancy, metering redundancy. So metering redundancy is maintained. So what is metering redundancy? It is सपोज आपका घर का जो मेजरमेंट आ रहा है वो तो सही है, ठीक है, आपका वो मेजरमेंट गलत नहीं दे रहा है, लेकिन if suppose a different metering device is giving a wrong result, but we are using that aggregated measurement, right? Means if area 1 consists of 200 households, so out of these 200 households, if 1 meter reads incorrect, that won't affect much in the power system context, means the load forecasting, because that accuracy, that error would be much smaller. But still we need to always have a check, to because monthly, on monthly basis, uh, the meter is malfunctioning, would have some system, like they would regularly check the power consumption profiles. You can also check, because you also have the idea that, well, based on the historical profiles, you also will have the idea that this is the basic power consumption, average power consumption profiles. Now this has increased, so then you can definitely query the concerned person regarding the malfunctioning part. But mostly you need to presently remote corrections and all these things can be made, but uh, whether the flag has to be raised from the customer side or it is raised from the uh, operator's end, that I also need to check once. But for the meter malfunctioning, what we need to regularly at least check the consumption profiles, and whether if it violates somehow, then accordingly a query would be raised. So that is the thing. Okay. Okay. So so mostly this was the overview. And okay, then DERs, so this is from the lecture itself. You can also see that what are the types of DERs: solar uh, energy systems, uh, solar photovoltaics, gas power plant. So this you have seen in the lecture itself, no need to. Now this is how cells are formed: modules, panels and arrays. So single cell, more than one cell, it forms a module. Multiple cells form module. Multiple modules forms panel, and multiple panels forms an array. And this is the energy source, energy conversion. This is the PV cell falling into the solar arrays. And after that, the energy conversion, because this is the DC part, so we need to convert it to the AC part so as to get the idea of get not get the idea, rather we so as to operate the equipments that runs in AC. So this is the grid connected mode of operation and off grid mode of operation, where the based on the battery bank, here we have the idea of charge controller. So these are the basic things. Block diagram you'll get in the lecture itself. So let's discuss the PV outputs, that MPPT. We need to operate the PV at the maximum power point. So MPPT tracker is also there. Okay. So based on this MPPT, here the the solar cell needs to be operated at this point of time. इस पे आपको operate करना है. Otherwise, आप उनसे maximum power extract नहीं कर पा रहे हैं. ठीक है. तो फील फैक्टर, अब कैसे सेल पैरेलल में करंट बढ़ेगा और सीरीज में वोल्टेज बढ़ेगा, इसके लिए आप इधर आइडिया मिल रहा है। और इसमें आपको दिख रहा है कि कैसे आपको हायर इरेडियंसेस, मतलब जिसमें आपको सोलर इरेडियंस ज्यादा हो रहा है तो ज्यादा इरेडियंस, मतलब आपको ज्यादा आउटपुट में करंट मिलेगा, तो कर्व आपका इंक्रीज हो रहा है ज्यादा इरेडियंसेस के साथ। ये विंड का पार्ट है जिसमें आपका विंड का ये शाफ्ट है, गियर बॉक्स है। ये मोस्टली विंड थोड़ा सी शोर के साइड में होता है जिसमें एयर का चांसेस हाई है। तो इसके बेसिस पे, मतलब ये लेक्चर से ही है, आप थोड़ा देख सकते हैं। तो थोड़ा सा क्वेश्चन आंसर्स है, इसको डिस्कस कर लेते हैं एक बार। तो ज्यादा नहीं है, अब थोड़ा आपको दिखाई दे रहा है ना, एनी आइडिया? जस्ट पार्टिसिपेट करिए, थोड़ा करके हो जाएगा। 10-15 क्वेश्चन है, मतलब एमसीक्यू टाइप। सो इसमें स्काडा सिस्टम कौन सा आंसर करेक्ट होगा? फ्रंट एंड प्रोसेसर्स स्काडा का बताया था। कुछ भी आपको, एनी रैंडम गेसेस भी आप टाइप भी कर सकते हैं, कोई बात नहीं। 10-15 ही क्वेश्चन है। SCADA system front end processors are interfaced with real-time data server, historical data server, operation workstation। SCADA में आपको डेटा मिलना है, ये डेटा आपको voltage magnitudes, power flows, power injections, real and reactive, power flows, रियल एंड रिएक्टिव, ये आपको देता है। ठीक है, तो फ्रंट एंड प्रोसेसर्स का किससे इंटरफेस होने से, सो ये ऑल ऑफ दी अबव होगा, मतलब सभी के रियल डेटा सर्वर भी है, हिस्टोरिकल भी है, ऑपरेशन वर्क स्टेशन सब है। ठीक है, सो व्हाट इज द फंक्शन ऑफ डेटा ट्रांसलेशन एप्लीकेशन इन स्काडा? डेटा ट्रांसलेशन एप्लीकेशन, डीटीए, ये डेटा ट्रांसलेशन एप्लीकेशन का पार्ट क्या होता है? मैनिपुलेट्स डेटा बिफोर दे आर प्रेजेंटेड टू द मास्टर स्टेशन, और प्रेजेंट डेटा टू द मास्टर स्टेशन, और एक्वायर्स डेटा फ्रॉम आरटीयू, और एक्वायर्स डेटा फ्रॉम द डिवाइसेस। ये डेटा ट्रांसलेट हो रहा है, तो इसके लिए क्या है? एनी आइडिया? ये होगा मैनिपुलेट्स डेटा बिफोर बीइंग प्रेजेंटेड टू द मास्टर स्टेशन, बिकॉज ये डेटा डायरेक्टली वो नहीं भेजता है, इसके लिए कुछ चेंजेस करके उसके बाद ही मास्टर स्टेशन में डेटा भेजता है। ठीक है, इसके बाद इन अ पीवी सिस्टम the PVR accounts for about dash percentage of the system's overall cost. Any idea?
समझ रहे।
Huh? So in the PV system, it array accounts for dash percent of the system's overall cost. Any guesses what would be the answer of this question? So it is 57%. Okay. Okay. The main impact of the series resistance in the solar cell, series resistance. One is shunt resistance, another is series resistance. So what is the impact? Any idea? So सीरीज रेजिस्टेंस लाइन में सीरीज है, so when the series resistance is in series with the load, so what it does is that the current that is flowing in the series resistance, the overall there is a voltage drop here. Okay, so with that voltage drop, the output voltage, that is v out gets reduced. Okay, so now when v out is reduced, with that our fill factor, what's about the fill factor? What we know about fill factor? Fill factor is v v out I out by v oc isc. Okay, yes, reduce fill factor. So ये reduce fill factor होगा. So V out reduce हो रहा है. So that means fill factor is getting reduced. So that's the right answer. What's the Boltzmann constant value? This is a fixed value. So because Boltzmann constant value is okay. This is a value. That's not. It is this one. 3 10 to the minus 3. Okay. Now this is the question. What's the percentage of uh, losses in a wind turbine's drivetrain? This is the point to be noted. Drivetrain. How much loss is encountered in the drivetrain of the wind turbine? You can write your answer in the chat box also. No issue. So it is any guesses? It will be 10%. Okay, it will be 10%. So light generated current in the solar short circuit temperature coefficient, cell temperature coefficient, cell short circuit current, and all of the above. Hello, am I audible? Light generated solar current in the solar cell depends on. So here it is all of the above because short circuit temperature coefficient, cell temperature, cell short circuit, all of the above. Okay. The blades in the wind turbine work on the principle of this is any random guesses. So it works in the principle of lift and drag. Okay. Type of tower used in the wind generation. What are the types of towers used for wind generation? Lattice, tubular, guide tower, and all of the above. Any random guesses? Types of towers used in wind generation. So all the types of towers are used, right? So the answer is all of the above. So Now, what is the function of yaw drive in the wind turbine? Yaw drive, what is the purpose of yaw drive? Measure wind speed, change gear ratio, all of the above. Turns the rotor around according to the wind direction. Turns the rotor according to the wind direction. Okay. So, some few more questions. Wind turbines are of how many types? This type is based on the axis. Based on the axis. Any guesses? So, 2 is the correct answer. Horizontal axis, vertical axis. Now, a controller in commercial type wind turbines are provided with data from from where does the controller gets the information about the wind? Controller. Emphasize on the term controller. So anemometer, it's the anemometer who gives the information because it gives the direction of the wind speed, means the direction. So based on this anemometer, we get the information. The controller gets the information that the direction of the wind flow, and accordingly the controller and the wind turbine rotates. Okay, the power generated by a horizontal type wind turbine for basic application. Horizontal type. Horizontal axis. 100, less than 100, 1000, greater than 100 kilowatt, all in kilowatts. So it's less than 100 kilowatt. So how many number of blades allow the wind turbine to operate at higher speed? Speed, so higher speed implies that the number of blades should be less or more or zero or single. So it would be lesser. Okay. Yes, correct. Yes. What does TSR stand for? Design consideration or of windmills. TSR. TSR stands for tip speed ratio. So we are on the last two questions, and that would end our session for today. So what does WECS stands for? Any idea? WECS. A. Yes. Wind energy conversion system. Correct. Solar radiation received at any point on Earth is called insolation, beam radiation, diffuse radiation, infrared radiation. This is the last question. Then we would end today's session and we would again meet on Saturday. Beam radiation. No, it's wrong. Any point on Earth. Solar radiation received. Okay, so it's insolation. Okay, A is the correct answer. So that's all for today. And if you have any queries, you can definitely ask now, or we can start our session on the next week's lecture. See, you just go through the next week's lecture, and we'll just discuss on them on the next Saturday, 4 to 6. And if you have any queries, then we can discuss it now. Any problems that you have faced while understanding the various operating principles of SCADA, the demand response activities, etc., etc. So you can ask now. We can Wind up today's session for the time. Okay, so let's end today's session. Okay, okay. You can leave. You can leave now. You can leave now. Okay. Thank you. Thank you. Thank you.